So good morning, everyone. My name is Ivàn Parras-Berrocal. I'm a postdoc researcher at CNRS in Toulouse. And my talk for today is entitled Understanding Mediterranean Surface Circulation through CEMEN's Product, a Multimodal Assessment. Okay. Well, sorry. Okay. So let me start with a brief introduction of the Mediterranean surface circulation. These circulations consist in the entry of Atlantic water through the Strait of Gibraltar, flowing eastward of the African continent to form this Algerian current. And once it reaches the Sardinian Channel, it splits in two main veins, one recirculating counterclockwise through the Western Mediterranean, and the other one which continues flowing through the Sicily Channel to the Eastern Mediterranean. This has a well-established pattern, and this circulation is well characterized by the mesoscale activities, typically with cyclonic circulation in the northern coast and with anticyclonic circulation towards the southern coast. Well, but how is going to impact the expected global warming on this surface circulation? Because this impact may introduce effects on regional sea level, marine species connectivity, also can lead to enhanced local surface warming. So despite its importance modulating the climate, the Mediterranean surface circulation has not been deeply assessed for the future. That's why last year we published this paper entitled Response of the Mediterranean Surface Circulation at Various Global Warming Levels, a multimodal approach. You can find the link to the publication if you scan the QR. And in this analysis, our main objective was to study in a robust way the response of the Mediterranean surface circulation at different levels of global warming. To achieve this goal, we collect all available information from fully coupled and regional climate system models from the MedCordex framework. And in total, we collect 28 multi-decadal simulations from 9 different regional climate system models. And among the simulations, 11 were historical simulation and 17 scenario projections, including low, moderate, and high emission scenarios from CEMIC 5 and CEMIC 6 exercise. So this was the largest ensemble ever used to analyze the Mediterranean climate. But before analyzing the future signal of at different levels of global warming, we start with a multimodal assessment. And here is where we are going to focus our talk for today, because it's where we use the CEMEN's product for this model assessment. Well, as you probably know, at the ocean atmosphere interface, where the momentum balance is driven by Coriolis acceleration, pressure forward, and vertical turbulent fluxes, the total surface current can be calculated as the sum of the geostrophic and ageostrophic terms. So for that, to compute the geostrophic term, we use monthly output from the models from dynamic sea level, and we compare the model outputs with two products of marine Copernicus. One is based on altimetry satellite observations, and the second one is based on Mediterranean reanalysis. For our assessment period, we took the 1993 to 2005 period because it was the longest overlapping period between the observations and all the historical simulation from all the models. And then to compute to validate the ageostrophic terms, we use model outputs from wind stress. And in this case, we also use Copernicus data. But in this case, we download from the data from the climate change service. We use the ERA 5 reanalysis data to validate the wind stress. But today we are going to focus just on the geostrophic term because it's where we use the Copernicus Marine System Service data, and also because the surface circulation is mostly driven by this geostrophic term. Okay, starting with the model evaluation. Here I show you the observations, the satellite observation, and here is the reanalysis. And as you can see, we found a meridional gradient with negative values in the northern coast, with switching to positive through the southern coast. And as you can see, we observe the pattern that I explained at the beginning with this entry of Atlantic water through the Strait of Gibraltar flowing eastward. And also it's important to note that the dynamic sea level gradients corresponds to these surface streamlines of the circulations. Well, when we add all the models, we found like a highly variability response of all the models, but most of them generally represent qualitatively well the spatial patterns, with the lower values at the northern coast, with the minimum located here in the cyclonic gyre in the Gulf of Lion, and the maximum related to those anticyclonic gyres, like here in the Alboran Sea. And the models who present the higher resolution are able to better reproduce this pattern, the observed pattern, while the model with lower resolutions, like UVEL, it's present like more deficiencies to simulate the current surface circulation. Then, to summarize information, we also use those plots, the Taylor diagram and the Taylor skill score. In the upper one, the Taylor diagram, we take into account in the X and Y axis the standard deviation, here with the curve with the correlation, and the semicircles corresponds to the root mean square error. Here we put with the start our reference data set, which is the satellite observation, and the gray dot corresponds to the Siemens reanalysis. As you can see, the values, the models who present the higher correlation and the lower root mean square error fall in the uncertainty of this behavior of the reanalysis. And here is summarized, here just the value of the Taylor skill score represent that one is a perfect reproduction. So models with higher resolutions are those which fall in this uncertainty of the reanalysis. Well, then we also analyze the variability associated to this geostrophic circulation. And here, from our reference data set, we observe that the highest values are located in areas where we find this mesoscale activity, like here in the Alboran Gyre, the Algerian current, and most of the models are able to reproduce those high values in the northern Alboran Sea. But contrary to the observations, it's a struggle to reproduce this variability localized in the Yera Petra gyre. And then we put we plot the basin average value in dashed black line. I present the value for the observation, and in gray for the segments. Each color represent a model, and we found that around 11 kilometers of horizontal resolution is required to successfully reproduce the observed average variability in the Mediterranean basin. Then we try to identify the main source of variability in the Mediterranean Sea. So we decompose the signal in 3 different frequencies. We decompose in interannual variability, seasonal, or intraseasonal. And from observations, we learned that the main source of variability is localized in the intraseasonal frequency, and most of the model also successfully reproduce this main source of variability. Well, now if we move to the future climate, here I show you the multi-model ensemble mean for at global warming level 2 and 4. And to really identify really robust signals where we find the robust changes, firstly, we add the hatchet areas to reproduce areas where changes are not statistically significant. And also we add a multi-model agreement criterion. This consists in selecting only those grid points where at least 8 out of 11 models agree in the signs in the sign of the change. Okay. Otherwise, we mask in white. So as you can see, at basin average, we cannot find strong modifications of surface circulation, but locally we identify two main regions here in the Northern Balearic Sea with a cyclonic, anticyclonic trend, and also here in the Southern Adriatic. As you can see from global warming level 2 to 4, the spatial pattern don't change too much, but the intensity almost double. This suggests a linear response with increasing global warming levels, and this is why we find here. Here I show you the percentage of occurrence of different circulation modes. To compute those circulation modes, we firstly calculate the vorticity, and then we define different modes subjectively, but based on the physics of each area. And this allows us to analyze those different circulation modes. So in the northern Balearic, we found this change from cyclonic to anticyclonic, while in the Southern Adriatic, we found an enhanced circulation, a cyclonic circulation at high global warming levels. Well, but now if we focus a bit more in detail for this Northern Balearic Sea, okay, we found this linear response. We found an increase of the anticyclonic frequency at high levels of global warming. But here, the models are not really good reproducing the values, the percentage observed and reported by the reanalysis. So this suggests that we need to apply an observational constraint to fix it. Well, so that's exactly what we did. And here we have, I show you the observational constraint. In the x-axis, I plot the percentage of cyclonic circulation during our assessment period, and in the y-axis I plot the percentage of the change of this cyclonic circulation at global warming level 2. In the middle is for all the global warming levels, and the last panel is for averaging all the global warming levels. And here the black line with the shadow area represents the observations and the error. So if we just keep the models that fulfill the observations constraint, which in this case are ENEA and CNRN RCSM6 model, we can see that using just those models, we now are able to reproduce the circulation pattern during the baseline periods, and without changing our conclusions, but because we are still finding this change from cyclonic circulation to anticyclonic circulation. From this analysis, we also find an emergent constraint, which is I mean, from the yellow line, we have a strong correlation, and we found this emergent constraint when the orange area cross the gray area. So, for example, here, averaging all the global warming levels, we can say that per global warming level, we have an emergent constraint of which results in a reduction of between 10 and 20% of this cyclonic circulation per global warming level. And from this analysis, we learned that semen products provide a key reference for evaluating the ability of regional climate ensemble to simulate present-day Mediterranean surface circulation. And you can find more results and conclusions in the paper. Thank you very much. And if you have any question, I would be happy to answer them.
Thanks a lot for the presentation, Ivan. Right on time also for the timing, so well done. So yeah, we have a few questions for you, so we will go to that part. So the first one being, how can we explain the differences, sometimes big, between the different models? Is it just about resolution?
Yeah, it depends not only about resolution, it also depends on the driving GCMs, the boundary conditions. Many things can play a role on those differences. And we also have to know that these runs that I'm using are historical runs, are not evaluation runs. So there are not following like real chronologies and are not the best to assess the present climate. But in this case, we just wanted to see how the historical runs performs reproducing the present climate, and then move to the future analysis, considering all the models as possible future response.
Okay, thanks a lot for the detail. Okay, so this one is cool. Do the 11 kilometers you've mentioned correspond to specific phenomenon in the Mediterranean, or would it be the same scale in other areas?
Not really. I would say that here, well, mesoscale structures in the Mediterranean Sea can have a Rossby radius around 15 kilometers and can be related with this, but not sure.
Okay, thanks. An extra homework to do, extra research. Great presentation. So what would be the consequences of the shift from cyclonic to anticyclonic?
Yeah, this is a really good question. In the original aim of our work, it was to study how global warming can impact to those changes in surface circulation, mostly related to connectivity between species, with an special focus on the northwestern Mediterranean. So it means that, for example, species like larvae from gorgonias, let's say, can be isolated in this jar due to this reversal of the jar. So, for example, this is one of the main consequence, and also we can have a local warming. If we see other analysis, other studies, like the ones carried out by Soto Navarro in 2020, I think, we can find like a local warming in this northern Balearic Sea, which fits with the place where we find the reversal of the jar. So it can also lead to this enhanced local warming.
Okay, thanks a lot. And do you know if some extra studies have been done to study these consequences, or is it just...
No.
Okay.
I think no.
Okay. Another question. Thank you for your presentation. It was a very interesting work. I was wondering if you saw any particular trend regarding the future circulation of the cyclonic Rhodos
jar. No,
yeah.
In our study, we didn't consider this jar because we mainly focus on those areas where we found a robust signal, or also we also include some of them which are relevant for Mediterranean circulation, like for example the Northern Ionian Gyre reversal, but we didn't focus on Rhodos Gyre at this time.
Okay, Okay, maybe another time.
Yeah.
Next question. Good presentation. Why don't you use salinity data to validate the model and evaluate vorticity?
Okay, so in this case, we just focus on surface circulation. So from model data, we just collect the dynamic sea level and wind stress. And from this model outputs, we retrieve the surface circulation. But we didn't have access at this point to salinity data. So we use the data that we succeed to collect, and that's the main reason.
Okay, thanks a lot. So for now, this is the last question. What is the lifespan of these cyclones and anticyclones?
What do you mean? What lifespan? I don't
Yeah, I
really.
guess how long would
The duration of each
yeah,
year. I don't know. I think that I cannot answer this question because in our data, we are using monthly values. So we are filtering out a lot of the signal that, for example, it can change with the winds or with a daily scale, let's say. But I cannot give you an answer using those monthly data.
Yeah, I guess it also depends on like the season and everything.
Yeah, and also we just pull all the models outputs and we compute the percentage of each cyclonic or our anticyclonic mode, but we didn't really analyze the time variability of this year. But it will be super interesting for future.
Okay, thanks a lot.
Thank you.
I guess that's the last question for your presentation. So thanks again. It was really interesting, and yeah, also there's some kudos in the chat.